Hey there, everybody. Today, let's talk a little bit about section 2.4, rates of change and tangent lines. And this is actually a review. We touched on this in section 2.1, that the average rate of change is just an algebra 1 slope between 2 points, right? And that'll just give you an average. If I ask you what the speed of an object or rate of change is exactly here, we wouldn't be able to find that. Well, we wouldn't be able to find it using algebra 1. Because that represents the slope of a tangent. And that's what we want to look at a little bit more in depth today, is this instantaneous rate of change is the slope of a tangent line, a slope at a single point. And we did talk about this tangent line problem, so we're just going to do a little recap here. I'm going to draw a graph, and if I want to find the slope of this tangent line, I'm going to use a little trick. I'm going to get 2 points. There we go. And this is going to be the point right here is the point x, and then whatever f of x is, right? Whatever my function value is, this will be my function f. And then I'm going to make this point, these points that I'm choosing, a certain distance apart. I'll call it h. And that means this x value would be whatever x is plus h. And now I can real easily label this point as the x value is x plus h, and then the y value will be whatever the function value at x plus h is. We could just plug it in. And then we're going to set up a little slope here for that to find the slope between those points. So I'm going to take y minus y over x minus x. And that's going to represent our slope between these 2 points. Now, if we simplify that a little bit, you get that the slope between those 2 points actually looks like this. And then the last step in this, to keep it from being the slope of a secant, the slope between 2 points, is to use some calculus. Let's let the value of h, the distance between the points, go to nothing. And that is the difference between the slope of a secant, which is this one, and the actual slope of a tangent. An instantaneous rate of change. It's just a regular slope between 2 points, but you let the distance between those 2 points go to 0. Okay, it's class time again. We've got one example, so I'd like you to try it or at least pause when you need to think about something. It's find the slope of y equals x squared at the point 2, 4, and write the equation for the tangent line at this point. So bottom line is to find the equation for any line, you need a point and a slope, right? So to write the equation of the tangent line, we will need a point, and we've been given that point, 2, 4, and the slope, but we need the slope at that point, okay? And let's do a little work on that. I'm going to show you 2 ways to do this. So looking at this graph of f of x equals x squared, that's the graph we're looking at. We're going to go ahead and set up just a generic point. There we go. And this is, we said f of x equals x squared. Okay, and then I'm going to pick a point that's just a little further away from there. I'm going to call that distance h. And I'm going to set up a slope between those points. Okay, so let's work on this. This is the point x, and if I plug in an x here, x squared, that's that point. And this is the point, the x value is now x plus h, so the value here for x squared would be whatever x plus h squared is. So we've got 2 x, y points. And if we set up this slope, we'll do x minus x, y minus y squared minus x squared over this x minus this x value. And that's going to set up an equation for a slope. Now remember, we want the equation of the tangent line for x. So our ultimate goal will be at the very end is to apply a limit. as that distance h goes to nothing. And that means we won't find the slope here. We'll find the slope as we move these 2 points closer and closer together. We'll find the slope of the tangent. So this is going to help us find the slope of the tangent value at x when this distance here, h, is 0. And we just have to do some algebra stuff. So I'm going to get to it. Pause me if you need to run through it. And then down here, when I simplify, I get h. And then if we simplify that, it's going to cancel out, right? And then I'll write this all out, 2xh plus h squared. And then the very last step will be to factor out an h. And what we found is an equation for the slope of this graph, y equals x squared, for any x value. All right, so let's go ahead. So we have to apply the limit first, and then we have that. If we apply the limit, we just let h equal 0, and we get 2x. And what this is the slope of the tangent for f of x equals x squared for any x value you want. And the x value that we want is this one. We want to find the slope at the point 2,4. So slope at point 2,4 means we're going to take this equation for a slope and we're going to plug in a 2. This line means evaluate. And we're going to get 4. So now we know we've got the point on the graph, and I'm going to slide this down. The point on the graph was 2,4. The slope was equal to 4 at that point, and so the equation of the tangent line is y minus y equals slope times x minus x. And you could leave it at that, or if you wanted to check it in your calculator, that's a minus 8, so minus 4. If you wanted to put this in your calculator with the graph of y equals x squared, this line should look tangent at the point 2,4. If it doesn't, we totally messed up. You can fix my math and send me an email. Okay, and then one more way to do the same problem would be to not do it generically first. We want the slope at 2, right? We just said that. We need the slope at this point. We know a point, we need the slope. So why not just let this be 2 and this distance be h, so this x value is 2 plus h. And then our 2 points don't look so vague. We plug in a 2, we get y equals x squared 4. There's our point. We're looking for the tangent line right there. And then this point would be the point 2 plus h, and then whatever I get when I plug 2 plus h in to x squared. And we can set up the exact same idea, but for a very specific x right off the bat. Y minus y over x minus x. And this would be 4 plus 4h plus h squared minus 4. And just zip through some algebra. And now I have to reduce out these h's. I'm getting 4 plus h. And when we apply the limit, look what we get right there. We get the actual, apply the limit. Once you apply the limit, you don't need to write limit. I'll just apply it here. Plug in a 0 for h, and the limit is 4. What that means is this is the slope of the tangent line at the point 2,4. And that's what we found out before. It's the same slope we got. We just had a little more work today because we found a formula for the equation of the slope for any x value. And then we said, oh, I'll plug in a 2 because that's where I really need it for this problem. And you can see when we go ahead and write this, we're going to get the exact same answer. Okay, what's the benefit of using this one? It's specific, so it's a little shorter. The benefit of using this one is if you were asked to find the slopes of tangent lines at a bunch of different points for y equals x squared. You wouldn't want to go through this every time. You could do it once, and then you could say, oh, the slope of that y equals x squared graph at 2 is 4. The slope at 3 would be 6. The slope at 10 would be 20. And you can rattle them off pretty quick. So looking at the problem, you can decide which one would benefit you the most.